Hi, everyone. Good morning, guys. Very good morning, all of you. Right. Very good morning, everyone. Pavan, Shruti, Pulkit. Good morning. So, all of you had your tea, coffee, hot water, juice, breakfast, everything? Everything you had or not? All you had or nothing? Yes, everything you had. That is plus subscription link, right? Those who are willing to take the subscription, plus subscription for this SSC JE, State AE JE, they can click on this link and subscribe to this plus courses, you can say, right? That is what, okay? Right. So anyone having any doubts in our questions up to yesterday's class, all of you? Anyone having any doubts anywhere? All of you? Any doubts anywhere, everyone? If any doubts are there, we'll just try to discuss those doubts first, right? If no doubts are there, we'll proceed to our discussions first, right? We'll proceed to our discussions first, right? Any doubts, anyone, anywhere? No? Clear, everything is clear? Okay, Aditi, good morning. Now we'll be going for this question, you can say. Right. How many questions we have done yesterday? In yesterday's class, we have done questions up to this 59, right? Up to 59 only we have done, or 60 we have done, everyone? 58 or 59 or 60? How many questions we have done? Right, okay. So this is 7th live test on which one? These materials, you can say, part 7, target SSC JE 2024 series we are having for the strength of materials. So this is my profile, you can follow me at which, and this is the referral code you have to use always, right? So whenever you are going for which one, whenever you are subscribing to the, anybody is subscribing to the plus and iconic courses, right, what is it you can say, use the referral code RPC, right? So this is a link I have pinned, you click on this link and subscribe to this plus and iconic courses, right? So these are all the subjects I'll be taking, and now this is 4,999, right? At present rate, what is the cost you are having? That 4,999 is the cost of 1 year plus subscription. Everyone, 1 year plus subscription cost is 4,999, you can say. So don't miss this opportunity, everyone, right? This offer is valid up to this 27th April only, right? How many days this offer is valid? That 3 more days it is valid, you can say, okay? 3 more days only it is valid, right? So this 1 year subscription 4,999, and when you are taking this 2 year subscription, Gaurav Kumar, good morning. When you are taking this 2 years subscription, at what happens, you can say 2 years subscription, it you will be getting at which one? This 8,999, okay? 8,999, right? So what is that referral code? RP Civil is the code, you have to use it, okay? Now, so this is a new batch started on. Everything is visible. So this is a new batch started on which one? This April 13th, you can say, right? April 13th new batch started, at KPS has started the irrigation engineering, and myself has started which one? This advanced surveying, you can say, right? Myself has started which one? This advanced surveying, if you just read, okay? Here, so this is these are the features, you can say, for this plus subscription. These are all the features for this plus subscription, right? Those who did not take, those who are not having this plus subscription, I'm telling about them, okay? Not for those who are already plus. Which one? Contour. Where is contour? Yeah, contour is, why this is getting, I don't understand. Is it blank screen visible now, or something, anything is visible, everyone, all of you? Blank screen is visible suddenly, I don't know why. Okay. For me this blank screen comes suddenly. How many questions we have done? How many questions we have completed, everyone, yesterday? Yesterday how many questions got completed? That 60 questions got completed, or 59th questions completed? Tell me, how many questions over? Right, this is over, na? So no, 59 question gets over, or not, all of you, right? This 59 question, 59th question gets over, you can say if you just read, is it? Now 60th question, I think this is over, right? Rubber we have selected, right? I have given the values also for this, na? Is that no? Now this one, yeah, this one is also over, na? Number of elastic constants, a complete isotropic, right? That fourth one we have done. Yes, this is also over, right? Now which one? 61, it is not over, na? So no, 61 it is not over, you can say, right? Got it? Arey yaar, this cursor is not moving easily. Why? I don't understand. It is like somebody hacked my system. It's like that. It is not moving. Right, arey yaar, why? What happened to this? Pulkit answered correctly. Yeah, esports videos and Gaurav answered, but you have to check it. Yeah, so from special, right? Pulkit and this is Shruti answered correctly, right? No. So what is it you can say? The strain energy of a beam is, right? What is the strain energy of a beam? If you just observe, beam means it is a bending moment. Beam is a bending member, or it is a which member? Tell me. Beam is nothing but it is mainly that bending member only, na? Beam is mainly that bending member or not? Beam is mainly that bending member, you can say, right? Beam is mainly that bending member, right? Now tell me, is it depending upon the shear force or it is independent of this shear force, you can say? That the strain energy for this bending member beam is given by integral, what is that you can say, mx square dx divided by which one? This ei, na? Mx square dx divided by this ei, you can say, if you just read, is it? Got it? Or 2ei or ei, which one it is? 2a, na? Is that no? That is your bending member. Bending member, which one? This bending member, which one you can say? Bending member means bending moment should be considered, you can say, if you just observe, right? Now next one, 62nd question, if you just consider, right? What is it you can say? Select the answer for the 62nd question, everyone. Second question, somebody answer. Pulkit answered correctly. We are in my mobile. I did not change the quality. It is visible like blur, 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 blur. Yeah. So here, what is that you can say? In a composite system subjected to which one? This temperature rise, right? So what is the composite system? I will explain, don't worry, right? Did I leave anything without explanation? No need to ask separately, okay? Right, don't worry. In a composite system subjected to this temperature rise, right? Composite means only one is there or only two members are there in the composite section. Composite section means that how many members will be there? More than one member will be there, then it is called as your composite section, na? So these are your two sections or not, right? These are your two sections, you can say, if you just more than one member is there, right? You know? So now one is which one? And with the ends constrained to remain together, right? Ends constrained means that what is it you can say? These ends are connected together, na? Ends are connected together, you can say, right? Ends are connected together. The component having the lower value of this coefficient of linear expansion will experience, right? So let us say this is having which one? Let us say that is a higher alpha. This is having which one? Let us say that is having this lesser alpha. Now what happens? Tell me if you just observe. What happens? Tell me if you just observe. temperature rise is there, right? Temperature rise is there. So temperature rise is there means, right, whenever this temperature rise is there, right, what is it you can say? Subjected to temperature rise with ends constraint. It is just, you can take bottom one, you can take top one. Any one we have to take, na? So no, one we have to take which one? It is not mentioned. One we are taking that higher alpha, one we are taking lesser alpha, right? You can take upper part as the upper material with this lower alpha and lower material with this higher alpha. There is no issue, right? Just for example, we have to take it, na? Just for example, we have to take it, right? So that is why we are taking it, right? Now tell me, whenever it happens like this, so whenever it happens like this, right, more alpha will be there means more expansion will occur, or this more contraction will occur, tell me. So they will be together, na? So no, with the ends constrained remained together, right? These ends are together. Now what happens, you can say first one, that alpha is higher means it will be extending up to this point under free conditions, na? It will be extending up to this point under this free conditions, na? Delta T temperature increases or not, temperature increases means it will be expanding up to this point under this free condition, right? Alpha is lesser means, right, what is it you can say? It can be expanding up to this point only under this, na, because of this lesser alpha. So these are your free expansions or not, everyone? Up to this point is clear? These are your free expansions, and up to this point is clear, all of you? These points are clear, everyone? These points are clear? These points are clear, everyone? These points are which one? These points are clear, right? Now, but what happens? Both are acting together, na? Both are acting together or not? Both are acting together, you can say, right? Both are acting together, if you just observe, right? When both are acting together, they will be expanding to same extent, na? Strain compatibility, right? Both are together means, when both are together, right, what will happen? When they are together, one will be moving, one will be subjected to higher deformation, one will be subjected to lesser deformation. That kind of condition will happen or will not happen? Together means it is a strain compatibility will be there, now all of you. Together means what condition will be there? Together means it is your strain compatibility you are having, you can say, right? So whenever there is a strain compatibility, right, what happens, you can say? Both together will be expanding up to certain point only, no? Up to this point only they'll be expanding finally, you can say, is na? So what is this one? This is your final expansion of these two, na? Is it clear now, every point? This is the final expansion of these two, all of you. Can you say this is the final expansion of these two? Because strain compatibility is there, they are together means instead of expanding individually up to this point and that point respectively, they will be expanding together up to certain point only, common point only. Is it clear now, Shruti? Others? Strain compatibility means strain in that first material is equal to that strain in that second material. That is a strain compatibility. Okay, original lengths are same, so deflections also will be same, na? Delta 1 is equal to the delta 2, na? Is that no? Yarvind, namaste. Is no? So what is it you can say? It is expanding to, yeah, Shruti, tell me. Strain compatibility means strain in both the materials is the same. Composite behavior must be having this strain compatibility condition. Suppose if they are not binded together, Shruti, if they are not binded together, that condition will happen, right? Yeah, if they are individually present, na, just one is placed above the other, right? Just you are placing which one? This one over the other, just like that, na. This will, there is no bonding between them. So higher alpha value, higher alpha material is expanding more, lesser alpha material is expanding less, right? But what is that mentioned? Ends are constrained to remain together, na. They are held together. They are remaining together means there is a bonding means compulsory composite behavior will come, and this strain compatibility conditions must be existing. Whenever it is a bonding is there, strain compatibility condition comes into picture definitely, right? Isn't it? Got it? So now both together will be expanding up to this point only, no? This red color one. Now tell me, it is expanding to which one? Yeah, they will try to behave like a single member. Yes, absolutely correct, right? Yes, no? So now whenever they are expanding like this, higher alpha material, it is expanding to a lesser value than the original na. So that means it is under this compression effect or not? It is under this compression effect na. So higher alpha material, it is under which stress you can say? This is under this compression effect you can say, right? That is your compressive stress it will be having. Okay? Yeah, it is getting stuck. I don't know what is the reason. Next, see my writing how it comes. Struck, it is coming like that. Now lesser alpha material, right? What will happen to this lesser alpha material? It is expanding to a value more than its capacity na, more than its precondition na. When it will happen, right? Because if it is under this tension only, this will happen na. That is under this tension, right? Understood now? So lesser alpha material is under this tension, higher alpha material is under this compression, right? So which one is the correct answer now? Lower coefficient of thermal expansion material will be having this tensile stress, right? Is that clear all of you? Is that clear everyone? Shall we go on to the next? Is that clear everyone? Right? PC needs some rest. Okay. Shall I go to the 63rd question? Right. Yeah, Aravind answered correctly. What about the others? Right. Right. Okay. So here we're just observing, right? What is that we have to go for? What is the question given? You can say. Right. No poll. It is not started. Oh, yeah. I thought poll is running already. Okay. 1 sec. 30 seconds time only. I'll do now. Otherwise. Yeah, Aravind, correct. Pawan, Shruti, Pulkit answered correctly. Right. So here, laptop keep it AC room. AC is not there. Okay. In our house. Right. We thought of taking now actually. The ratio of hydrostatic stress to the volumetric strain within the elastic range is called as, right? Hydrostatic stress rate. What is the hydrostatic stress? You can say that uniform hydrostatic stress means it is the same stress in every direction na, divided by this volumetric strain, right? What is that? That is your bulk modulus na. It is not the elastic modulus, right? What is that elastic modulus? Normal stress to this normal strain na. Shear modulus is nothing but your shear stress by this shear strain na. Both elastic and shear modulus. Is it so? No, nothing na. It is not like that. So which one is correct now? Bulk modulus is the correct one or not everyone, right? Bulk modulus is the correct one. You can say just of that. Bulk modulus only will be the correct one. You can say. Got it? Right. 1 sec. Just some questions are left actually here. One sec. Right, I'm just uploading these questions. Right, 63 questions are over. Now we'll be going from which one? This is 64th question onwards, right? 64th question onwards. Yeah, you have seen that question. Very good. 1 sec. this is 64th question, you can say. So shall I start the poll for the 64th question, right? Select the answer of you. 30 seconds time I am giving. I told you now 90 questions are there. We are doing the 64th question, right? Just 1 or 2 classes, it will be over. Okay. First chapter gets over, right? Next we'll be starting the SFD VMD because that is most important chapter afterwards now. Or principal stresses shall I go for? First what is that you can say? Simple stresses and strains, principal stresses and strains, and what is that you can say? Next one is deflections, SFD VMD, right? These 4 chapters are very most important topics for any examinations point of view. You want me to take principal stresses and strains or SFD VMD, which one? Or my wish is to take principal stresses and strains. "90 questions are there after this chapter is over." That is what I am asking. After this chapter is over, the force acting normally deflections will go at the end, because for getting some of the deflections, SFD BMD we should know. Is not BMD especially we should know for getting some of the deflections, isn't it? Moment area method, right? The more moment area theorem, right? Conjugate beam method, if you try to use now, SFD BMD we should have idea, right? For that purpose, after SFD BMD only we should go for these deflections, right? Before that we don't go. Okay, I'll go in my own way, don't worry. Right, the forces acting normally on the cross section of a bar shown in the figure below introduces, right? What is it you can say? So external load is your tensile load, na? External load is your tensile load. This is a tensile load will be creating which one? This is a tensile stress only, na? Yes or no? Next, the 65th question, right? Try to select the answer of you. 30 seconds time I am giving. External force is your tensile force, therefore the stresses comes to be which forces? If you just observe, those are your tensile forces only, is not? Isn't it? Right? Pavan, Shruti, Pulkit answered correctly. So what is that you can say? A material is said to be perfectly elastic, right? When it is said to be perfectly elastic, when it is said to be perfectly elastic, when it is perfectly elastic, it regains its original shape and size on the removal of this load, na? Yes or no? When it is regaining original shape and size on the removal of this load, that is called as your perfectly elastic, you can say, is not? It regains the original shape partially. When it is regaining it partially, can you call it as a perfectly elastic, or you can call it as partially elastic? You can call it as this partially elastic, na? Perfectly elastic you cannot call it as, if you just upgrade, isn't it? You cannot call it with the name as perfectly elastic in that case. It does not regain. So this is which one? This is a fully plastic, na? This option C is your fully plastic or not? It cannot regain at all, right? So this is one, right? Perfectly elastic means that first option only correct answer or not, right? So shall we move to the next one? 66th question, right? Here select the answer of you. 1 second. 60 seconds time I am giving. Try to solve this all of you now. Mostly in next class, day after tomorrow, on 25th, we may complete this first chapter. On 27th, we may start new chapter. No, tomorrow only. 24th, we may complete. 25th, definitely we'll start a new chapter. Okay. Up to your examination, SSC JE examination, these are going on. Okay, don't miss them. Bring any other friends, those who are preparing for SSC JE also. SSC JE I am talking about. This SSC JE up to SSC JE exam is there. After SSC JE exam over now, I will take for the state exams. That is what. Because time is not available now. Time is not available now. So first we have to complete subjects one time. Yeah, Arvind correctly answered from YouTube. First we have to complete all of them one time, then again we'll come back. That is better. If we'll start this state also, na, only strength of materials we can do up to your SSC JE examination. No other subject can be completed. AB and AC are the cross sections of which one? This bronze and copper bars equal to the length, equal lengths, right? Both are having the equal lengths or different lengths? Tell me. Both are having this equal lengths, na? Now, sigma B and this is sigma C, right? What is it you can say? Sigma B and this is sigma C are their respective stresses due to what condition? Tell me. Stresses due to the respective loads, are their respective stresses due to that load P, right? A load P is applied on them, and individually bronze is having the stress sigma B, copper is having the stress sigma C, right? Now, that is PB and PC are in the loads shared by them, right? What is the relation between this PB and this PC, right? How can you get that relation between this PB and this PC if you just observe? You can get it like which one, all of you? Here, both are having that same means. So what is it you can say? Epsilon B will be equal to that epsilon C, no? Epsilon B will be equal to that epsilon C we are having, or not? Epsilon B will be equal to that epsilon C, you can say, right? Means what is that strain compatibility condition or not? Yes, strain compatibility condition. And what is that epsilon B? Stress in the bronze divided by this Young's modulus of this bronze equal to stress in the copper by which one? This Young's modulus of this copper. Okay, like that we are having. So this is a relation we should have, right? And what else we should have, right? The sigma B by this sigma C will be equal to, right? What is it you can say? Sigma B by this sigma C will be equal to Young's modulus of this bronze divided by this Young's modulus of this copper. Now, right? Can you take it like this? Now, what is the total load? Total load is shared by both, na? Load taken by this bronze plus this load taken by this copper, right? Now, tell me which one are correct if you just consider. This is first one is correct. Second one is correct. So, PB is nothing but your AB into this sigma B only, no? This is correct, right? Which one is the correct answer now? All of the above is the correct answer, right? So that PB is nothing but your which one? Area of cross section of this bronze into stress in the bronze plus PC load taken by this copper is what? Area of cross section of this copper into that stress taken by this copper, you can say, right? Got it now? Isn't it? Clear now, everyone? Shall I move on to the next? 67th question, shall we move on to? Composite, it is mentioned, equal length are the respective sections due to, right? These are the loads shared by. So now, automatically, right, when composite section is given, if nothing is mentioned, no specific condition is mentioned, means you have to consider they are following this composite behavior, right? Yes, no? Okay. They are following the composite behavior by default, we have to consider, right? Composite behavior is there means strain compatibility also must be there by default. If it is mentioned that they are behaving individually, then you don't consider that. Higher alpha material will be expanding more or contracting more. Lesser alpha material is expanding less or contracting less, you can say, right? That is what. Got it? 67th question, shall we go for? Select the answer, everyone. Will get answered correctly. Arey yaar, more time I have given, extra time, unnecessary time. Okay, I'll end the poll. Anybody from YouTube? Nobody answering from YouTube? The ratio of this shear stress and this shear strain of an elastic material. So what is that? Young's modulus is what? Normal stress to this normal strain. Rigidity modulus or this rigidity modulus or which one? Rigidity modulus is nothing but your which one? This is C equal to that N equal to rigidity modulus or this is shear modulus, right? G equal to C equal to N equal to tau by 5. And bulk modulus is equal to which one? This is a normal stress by this volumetric strain, you can say. Na? So which one is correct? Both modulus of rigidity and shear modulus, right? We can call it with any name, na? We can call it with any name or not? We can call it with any name, you can say. Na? Right. So shall we move to the next one, everyone? So this 68th question, if you go for it, shall we? So we'll start the poll, right? You observe this A, B, C, D properly and select the answer, right? This is your C and this is your B. Okay? Don't take that 5 millimeter as B. Take that 5 millimeter as a C. That is what I said. You observe and select the answer. You are not listening. Who is that cute fellow? Not listening to me and answer after the another. You. I was telling that already. You observe BC properly and select the answer. So you have to be careful. Don't be in a hurry always. Okay? Pulkit only answered correctly. Right. So what is it you can say? A load of this 1960 newtons is raised at the end of a steel wire. The minimum diameter of this wire, so that the stress in the wire does not exceed this 100 millimeter square, right? So what is the stress you can say? If you just observe, stress is nothing but your load by this area, na? Stress is nothing but your load by this area, right? Load divided by this, what is that you can say? That diameter it is mentioned, na? You are asked to identify. Diameter means it is of which shape? Circular shape, na? So pi by 4 into the d square, pi by 4 into the d square, you can say, if you just got it. So what is that? Sigma 100. 100 equal to, what is the P? 1960 divided by which one? This is pi by 4 into, what is it you can say? That is your d square, right? Now tell me how much is the d value comes to be? The d square is equal to 1960 by pi by 4 into, what is it you can say? 100. So what is the d value? Tell me. D value comes to be how many millimeters if you just observe? D value comes to be how many millimeters, everyone? 4.5 or 4.99 it comes to be? 4.5 it comes to be or 4.99? Which one it comes to be? Check it and tell me. 4.99. So 4.99 means that which one we have to select? This is C, that is your 5 millimeter we have to select now. That 5 millimeter we have to select it, right, like that. Okay, so we'll close the session. In tomorrow's class again we'll continue. Okay, thank you all of you. Tomorrow mostly this first chapter will get over. Okay, thank you all of you. Any doubts, anyone? Thank you. Have a good day.